Good morning. So today we're going to look at rules of exponents and kind of just exploring these rules of exponents, and we know what they are, so hopefully we can now put them in words and symbols a little bit. So I want you to write out all the factors, then compute each of the following products and quotients, assuming A and B are not equal to 0. Then write a specific rule for how you can find the product quotient without writing out all of the factors. Okay, so let's do the first one together. So what I mean by a to the fifth times a to the third is a to the fifth is a times a times a times a, 1, 2, 3, 4 times 5. And a to the third is a times a times a. So, how many a's do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. So, this is a to the 8th. So, what does that mean? So, that means when you have like bases, and you are multiplying, well, how about this? I'm going to say this. When you are multiplying like bases, so it's important that they are like bases, right? So when multiplying like bases, you add the exponents. So that would mean that if you had x to the a times x to the b, you could just say x to the a plus b, like that. Okay? Alright, so y'all do the rest of those. So take a minute and do the rest of those, and then we will work through the other ones. Alright, so we've got a to the fifth raised to the third. So that means what? A to the fifth times a to the fifth times a to the fifth. So 3 times, right? So a to the fifth times a to the fifth times a to the fifth. So that'll be a to the 15th. So basically, if I have all of these factors here, what else could I do here? If I'm raising a base to another power, so if I'm raising a base with an exponent to another power, I can just multiply those powers together. So that would mean that you would just multiply those exponents a and b. Okay, here we've got a squared b raised to the third power. So this would be a squared b times a squared b times a squared b. So how many a's here do I have? So I'm going to have a to the 6th, b to the 3rd. Or what else could I do here? Even I'm going to distribute that exponent there. When you're raising, this is multiplication. It has to be multiplication right there, though. There are no addition signs. These are just monomials. Okay, when you are raising a monomial power, you can distribute that power inside. So when you are raising a monomial to another power, you can multiply each exponent. By the power. So, what I mean by that is if you've got xy raised to the a power, you can say x to the a power and y to the a power. So same thing here. So a over b to the third power, so that means a over b times a over b times a over b. So that's going to be a cubed over b cubed. So same thing, you're going to just distribute that when you are dividing. When you are raising a monomial that's dividing, if you're dividing a monomial, then you can just distribute the exponent as well. So let's just say this. Okay. All right, what about here? So we've got a to the 6, so that's a times a times a times a, 1, 2, 3, 4, 5, 6, and then we've got 4, 1, 2, 3, 4. So what happens here? So I'm going to be left with an a squared, right? So when you are dividing monomials by another monomial, if they are the same base, you can subtract the exponent. So if I have x to the a over x to the b, that's going to turn into x to the a minus b. All right, let's look here. So a to the 6th over a to the 6th, so that's a times a times a times a times a times a over a times a times a times a times a times a. So what's going to happen to each one of those a's? They're going to go, you're just going to be left with 1. So what am I going to do here? So I can use this rule here. I'm going to just subtract my exponents, right? So when I subtract my exponents and it gives me, right? So let's just say, I'm going to say 6 minus 6, right? So it's going to be a to the 0. So anything to the 0 power is a 1. Okay, so what about here? We've got a to the 4th, a times a times a times a over 1, 2, 3, 4, 5, 6, 7. So what happens here? I'm going to be left with a 1 in the numerator and 3 a's in the denominator, right? But how can I can use my rule 5 to simplify, right? A to the 4th over a 7th. So that means I'm going to say 4 minus 7. So it's going to be a to the negative 3. So any negative exponent can move to the denominator or the opposite where it is and become positive. All right. So take a minute and try to do number 8, and we'll do a together, and then I'm going to let y'all do b over here for number 9. So take a minute and work through these quickly. Okay. So here we've got 5 times negative 2 here. So nothing is raised to a power, so it's 5 times negative 2, which is a negative 10. And these are not the same, so this is going to be k to the 4th c squared. This is y to the 6th raised to the 2nd power, so this is going to be y to the 12th. This is going to be a negative 3 a to the 0 power raised to the 3rd, but a to the 0 power is just going to be a what? A 1. So this is going to just be a negative 3 raised to the 3rd power. So a negative 3 raised to the 3rd, so that's a negative 3 times a negative 3, which is a positive 9, times a negative 3, which is a negative 27. Things like this you will not be able to use your calculator, so just kind of remember that. Okay. Here we've got a negative t over 2 raised to the 4th power. So that means I'm going to have a negative t raised to the 4th power over 2 raised to the 4th power here. So a negative raised to the 4th power, so it's a negative times a negative times a negative times a negative. So that's going to turn into a positive. So this is going to be a positive t to the 4th. And 2 to the fourth is 2 times 2, which is 4, times 2, which is 8, times 2, which is a 16, right? So here we've got 16 x to the fifth over 8x to the fourth. So here I'm going to say 8 and 16. So what is 16 here? I just had it here. So 16 is 2 to the fourth power. I'm going to use my rules of exponents to help me out here. And 8 is going to be 2 to the third power. So here I've got 2 to the fourth and 2 to the third. So what am I going to do to those exponents? I'm going to subtract them. So it's going to become 2. X to the fifth over x to the fourth. So it's going to be 2x. So what can I also do here? 16 divided by 8. That's just like 16 divided by 8. So I can say 16 divided by 8, which is a 2, of course. But sometimes you like to see it that it is a exponent. All right, what about this? 5 to the negative 2. So to simplify that, I do need to make it positive. So that's going to be 1 over 5 squared. So this is going to be 1 over 25. Okay. All right, let's look at number 9 here. So number 9, it says find the values of a and b that make each expression equal to 1. So if this expression had to be equal to 1, that means that each one of these exponents, when I simplified, would have to be equal to what? To 0. All right, so let's look here. So I have x cubed y to the negative 2 over x to the negative fourth y to the negative first. All right, so when I was to simplify this, this is going to be 3. Yeah. 3 minus a negative 4, so it's going to be a 7. A negative 2 minus a negative 1, so it's going to be y, yeah, to the negative first power. Okay, what about here? I've got x to the negative 8, so this would be x to the negative 8 minus b, yeah. And then I've got y to the a minus a 7. Okay, so if I were to simplify this, let's not do it that way. Let's keep it. Let's keep this here. All right, let's keep it like this. Now what else could I do here? So let's do this. So x to the 7th and x to the negative 8. So I'm going to add those. So it's going to be x to the negative first power. Y to the negative first and a 7. So I'm going to subtract those. So negative 1 minus a 7 is a negative 6, right? And then I'm going to have this y to the a power, and I've got this x to the b power here. So let's just do this. X to the negative 1, let's make this, let's make them all positives. Sorry. So I'm going to leave y to the a power up there, x to the bottom, y to the 6th, and x to the b power here. Okay, so let's think about this for a second. So what does y need to be? So y to the a here, to make this go away, what does it need to be? Okay, so it's got to be equal to a 0, right? So a would need to be equal to a negative 6, right? What would b need to be equal to? A negative 1. Okay, I want y'all to try to do b for me. Okay, so let's simplify this one here. So I've got -2, so I say -2 minus a -4, so that's going to be a 2. 3 minus a -1, which is going to be a 4. Okay, this one is your B, and that's a 6. I'm terrible, I'm sorry at that. So let's kind of do it the same way. This is your B, and this is your A up here, and this is your 6. That, try to make it a little better there. That's a -5. So this is still like over 1, so it's the same thing. So you can say 2 and minus a 6, so that turns into X. So 2 minus a 6, which is going to be a -4. Y to the 4th minus a -5, which is going to be Y minus, turns into a positive there. And this is going to be X to the B, Y to the A. Okay. So I can just move this 1 to the denominator, so Y to the 9th, X to the B, Y to the A, over X to the 4th here, right? Alrighty, so these would have to be opposite signs here. So this one's in the numerator, one's in the denominator. So that B right there would still need to be a 4, right? Because if I made that a 4, 4 minus 4 is a 0, which makes that a 1. And this Y here, the A here needs to be the opposite. They're on the same level, right? So it would need to be the opposite sign. So this would have to be equal to a -9. Okay. All right. That is rules of exponents. Let me know if you have any questions.